electricity is what? Electricity is one form of the energy. Yes or no, Namisha? Now, before I start my theoretical explanation, I will ask you this subject. What are the kind of different energies we have? Start, explain me. What are the energies, different kind of energies we have?
Heat.
Heat, okay, good. Agla. Shravani told me heat. Oh, electrical, okay.
Mechanical.
Mechanical. Chemical energy, potential energy.
Kinetic energy.
Kinetic energy.
Mechanical energy.
Mechanical energy.
Light energy.
Huh?
Light energy.
Oh, light energy. Yes, light energy.
Solar energy.
Solar energy. I wouldn't so much use. Huh? Hydroelectricity. Hydro. That is a part of
Thermal energy.
Thermal energy, heat energy.
Tidal energy.
Tidal energy.
Nuclear energy.
Nuclear energy, my good, very good. Yes.
Hydrogen energy, not it was related to development.
Okay, come on, tell me.
Nuclear energy.
Wind energy. Wind energy. Come on, come on. Likewise, my God, so many energies all people are talked about, but there are many more. Okay, my dear friends. Now, I'll give you simplest question. So before we end up this class, not today, the session, the camp, the workshop, if you can come out with this answer for this question, yes, I will be the greatest, luckiest, happiest person on the globe. Shall I ask you the smallest tiny question? Are you all ready? People have found energies all across the globe. Different forms of energy they found. Yes, sir. But however, they all convert all these energies to electrical energy and then they transfer to one place to the other. You just check it out, okay? But here is a question, like, why is that everybody, whatever energy they found, like he said, or Vivek said that wind energy. Suppose in Anandapuram district, there are a lot of wind farms, lot of thousands of windmills working there, because a lot of wind is there, okay? So immediately what they did with the wind turbine, they converted to electrical energy and connected to the grid. That means whatever energy they found in the wind, that was the energy captured by the wind farms or windmills, wind turbines, converted to electrical and then they fed into the cable. The cable is going all across. We are utilizing whatever way we want. Suppose you want wind here, what is it you are using? So, here is a tricky question. What happened when I asked this question in one school in Hyderabad? One girl answered me, sir, what happens in windmill? This is your question, no? That how this windmill works like, okay. What happens in the windmill? So wind goes into the windmill, that comes out of the fan when you switch on. This is what she answered, okay? But she didn't know that it gets converted to electricity there itself. The electricity comes here and then we make it back to
mechanical energy.
Mechanical energy and then the blade mechanism, the angle and all, it pushes wind on us, the local wind, not that the wind is coming from the cable and all, right? Okay, anyway, what is that I wanted to say about all this? About his wind. And somebody you told me about physical, potential energy, okay? Potential energy, I am there in a lot of power plants, okay? So, if you are interested, Naimisha or Sachinarana sir, you know, dad's friend, Sriram's friend, Sachinarana Dhavaleshwar, GTPS used to work as an assistant engineer. That's Supradeep's dad. He appointed as a divisional engineer there in CDL. So we are very lucky to go and see that hydro dam, the potential energy based what he is talking about. For example, see, and now here is the time for us. Hey, like how potential energy is captured, you know, what is potential energy? Can anyone say to me? PE, what is PE? Come on, tell me. Tell me now, what is PE? What is PE? Come on, tell me. MGH. What is M? Mass. Okay. And what is G? Gravity. And what is H? Height. Okay. Now, you know, so much huge potential energy is given by our God, the Sun itself. The God, Sun has become a big God for us. Why? Because of water cycle. You know water cycle? Because of sun energy, water RC and all, water will go up and down. Then what happens is that due to the water cycle, rains comes and rain on all the mountains and all the stuff like and naturally formed that particular See what is that? This is a sea level, for example, this is a sea level. Okay, my dear friends? That is the sea level. From this sea level, we measure the heights. Because I need to know what is the height for that particular reservoir. The reservoir is catching the water whenever rains coming up, right? You know that water cycle, like how the rains comes and all that, I don't have to explain. But when rains comes up and then all the water captured by the naturally formed reservoirs, so-called reservoirs. And all these reservoirs will have a common center point. Suppose the tank has got, suppose you have a water tank. So definitely you can find out a center point of the water tank or not, up above your home. Similarly, this reservoir is also a big water tank which is placed much above the sea level, much above, for example. And then, so there will be a center point. From that center point to the sea level, the H is there. The H has come from there. Are you following? Similarly, you know, if you can measure all this water's mass, for example, this is a 1 liter bottle. It will have its own mass or not?
Yes, sir.
Can anyone tell me what is the mass of 1 liter water bottle?
9.6 somewhat.
Can tell me, anyone tell me what is the mass of this 1 liter water bottle? Roughly, if you can tell me, roughly, like a ton or kilos?
Kilos only, sir. Not
How many
grams.
kilos?
It will be 980 grams.
Okay, now we can take roughly, for example, say 1 kilogram, 1000 ml, 1000 grams. Okay, so similarly, even that many liters of water will have their mass, yes or no? Just imagine, how do we calculate mass of the water there? Just try to understand, Vinita, it's a very interesting point. That's where I told you about this particular children's circuit lab is not just simply handling the circuits and the projects. It is also connecting your all education, all the physics practical learning, okay? Is it very interesting for you now? See, now all this particular water has got mass, and how do we measure the mass? So simple to measure the volume, okay? And just imagine if the reservoir's length around 100 kilometers and then around 25-30 kilometers of breadth and then depth around 0.81 kilometers and just if you measure, multiply all these three, L into B into H, what you get is volume. Once you know the volume, the density of the water is known, with these two, you can find out the mass. Yes or no? So once you know the mass, once you know the height from the sea level, and then anyhow you know the G. Newton, great scientist, invented very much. Now if you multiply all these three, you will get the energy, potential energy, how much it is there in this reservoir at that point of time. Yes or no? So now, once you know the potential energy, and what is that you are doing here, you are taking a tunnel, you are making a tunnel and send the water to a water turbine. From the water turbine, you run an alternator. And then, when the alternator runs, you get the electrical energy output. So, whatever energy you have here, there as you said your potential energy, wherever naturally formed reservoirs, from there, you are converting all that energy what you have there in the reservoir to electrical energy and feed to the lines. Similarly, wherever you find coal mines like Ramagundam, that is all chemical, right? And you burn it, thermal, heat energy, and then you turbine, mechanical energy, and then alternator, electrical energy, again connected to cables. So that entire coal energy, the chemical energy, is now converted there itself in Ramagundam around 3000 megawatts. Just imagine, even Vijayawada around 3000 megawatt. Likewise, wherever there are thermal power plants, there you are producing thousands of megawatts and again connecting them to the national grids or regional grids of the electrical distribution power lines, 220 kilovolt lines and all. Okay, are you following what I am saying? Now my question goes, my dear friends, wherever there are energies like this, like sun energy, wind energy, potential energy, chemical energy, oh my God, we have discussed about many of the energy. You just name energy, I can give you the example of it, how we produce and to convert to electrical energy, and then we connect to the cable control, okay? Distribution line. Now here is my sweet question to all of you. Why is that everybody, whoever find energy at different locations, ultimately convert into electrical and then distribute all across the places wherever we need it? So answer this. Okay, Shravani, answer.
Sir, because for our daily life uses, most of it is electrical energy. With
Okay.
the electrical energy, we can do many things.
Okay.
Like to produce light from bulb, we need electrical energy. To need fan, we need electrical energy. And to build, even the buildings also.
See, my question is not today's that we are depending upon electricity. Even before, they started converting all the energies to electrical. So, we have converted all energies into electrical and then we brought it down. Okay, so why is that firstly they just converted to electrical?
Sir, actually we are first generating electricity by burning fossil fuels and all. It is non-renewable energy, so at some extent it will be extinct. So to give this electricity to the future generations and to carry on the scientific works, we are now storing or producing, generating this in a lot of massive scale, so that it is useful to the future generations.
Okay. Anybody else? Yes?
Electrical energy is able to transfer faster from one place to another.
Okay. Anyway, any other? He said something nice, faster. Good. That is good.
So, electrical energy is a non-biodegradable and it is non-harmful, it's eco-friendly, and when the scientists in 15th century, 16th century, when they discovered and when they invented, they thought that everything which they are using is non-renewable, so that if it is converted into electrical energy, it can be used to the future, and it is a lifelong process where it can be produced, and it is the simple way which we can control whole the world.
Okay,
Yes.
good. Oh, you want to explain something? Okay, go ahead.
Sir, in all energies, only electrical energy is a renewable source, sir. So every sources are converted into electrical energy, so we will get
Okay. Actually, good. A lot of children explaining in a lot of different ways, but still, I am expecting for much better answer. Okay. So try all these 4-5 days while you are there with me. If you extend it for another 1 day also, I have no problem. If you are so interested. So here is not time bounding, it's not time bounding, but it's subject bounded. Okay. So think about it. Okay. You keep thinking about it. If you can come out with an answer in this 1 week time, then I will be the most happiest person in the world. Okay. Think and keep thinking about it. Okay. So as we talked about that electrical energy, how it and now how do we produce electricity in two different ways. One is, alternating current and direct current. Direct current is always from batteries, chemicals, and then alternating current is from alternators, like the motors kind of dynamos. So some mechanical energy has to go inside and they rotate the machines, and then there are a lot of things happening inside. Great goes to who? Michael Faraday, great inventor of all this kind of dynamos and all with these Faraday's laws. Now having transformers to transfer the power from one place to the other. That's also basically on Michael Faraday's. Okay. Now the thing is, you all know about the story, Michael Faraday's story, how he invented all this, like at what age he is into, about the MPDV. You all know about the story? How he became that great inventor of all this. So now, at least I'll ask you this question. Electricity produced from chemicals is first, or electricity produced from that dynamos and alternators is first? Yes. Okay. So a lot of research is already started and they are doing a lot of experiments, electrolysis and all whatnot. They are using it already, electricity produced by chemicals like batteries and all. Okay. So all the energies, all the electricity from chemicals and all this stuff like batteries and all, basically direct current. It is not alternating current. So you need to know the difference between electrical alternating current and then direct current. So in electricity, basically, while it is there in two different forms. One is direct current form, other is alternating current form. Yes or no? So in direct current form, the electricity is always passing through the conductor directly. It is not jumping there and here alternatingly. Okay, so alternating current, the name given to that is because the electrons are not flowing in the conductor directly. They are jumping like following a sine wave, like up downs. So up times are positive times, negatives are positive, negative times with reference to ground level. So that's where we call it as alternative. For example, to make you understand, you know the meaning of alternative? You know, suppose say in this route the bus is low, sorry, that's not for this example. Anyway, you know alternative, like if I say that I will come alternative days, that means if today I come means tomorrow I don't come. Means likewise one day present, one day absent is nothing but alternative. Now, whenever there is present and absent, then automatically frequency comes. Like how many times you are present, how many times you are absent during the time. So when something is with respect to time is nothing but the frequency. You understand? So number of cycles per second in that conductor flowing is nothing but the frequency. Okay. Now no one told you, no one tell you what exactly is that how many cycles per second. In India it is 50. In America it is 60. The cycles are different, the frequency is different of the power. So what I mean to say, here when we wanted to talk to you, before I go into alternating current, I wanted to talk to you about direct current. So for direct current, what are the things we have? Direct current, okay. So in the electrical energy in the form of direct current, because we are mainly working with a lot of time with direct current. So what are the parameters we need to know? One is voltage, other is current. Current in the circuits, we write them in I, okay, and we measure them in amperes. So, and also here resistance, volts. So power for this is nothing but P. Power is P. Power. So power is equal to P measured in watts. And okay, power in DC is watts, and it's nothing but the voltage measured in volts, DC volts, and the current in amperes, DC amperes. Okay, and resistance anyway it doesn't bother, DC or AC. Okay, it's a load, basically it's a load. But value given to that is symbolically ohms or the right ohms. Okay, we measure, and in fact the people they show it is resistance in circuits because every electric component in the circuit has got their symbol. So this is the resistance. Okay, I'll tell about those particular things after 5 minutes. Now for the power in the form of DC, we need to know about voltage of DC power, current of the DC power, resistance and all. Now what I wanted to tell you about the formula behind this, P is equal to V into Y. In DC, P is equal to V into Y. So whenever you measure the voltage and multiply it by the current flowing in the circuit, that is going to be the power consumption of the circuit. Every circuit will consume power. For example, suppose say if I switch on a lamp, 12 volts lamp. You have 12 volt batteries for inverters at home, right? So the best example for you is that if you go for 12 volts any bike bulb, 12 volt bike bulb, okay, then you need to have an ammeter and a voltmeter. So connect voltmeter across the battery, you will know what is the voltage is going on the battery at that time, okay? And now connect the ammeter in series with the bulb and keep the bulb across the plus minus of the battery. Then because bulb is glowing now, at that time your meter, the ammeter is showing the current pulled by the bulb. And you note down the amperes of the meter, ammeter, and then the voltage reading of the voltmeter. Then you multiply the both, then you will come to know what is the power spent by that particular bulb. Is it interesting? And if you see, look at the bulb, 35 watts is written. That means at that time it is consuming 35 watts. If you multiply this two, okay, at 12 volts, at some ampere is pulled, if you multiply the both, then ultimately you find the answer nearby 35 watts. So, they have decided this bulb, 35 watts bulb will give this much of light. That is required for scooter or bike, whatever. So, what kind, so to dissipate that, to consume that much of power in the bulb, how do they design the things inside is nothing but resistor. The value of the resistance inside the bulb, the filament, they reduce to such an extent that allows the current to that much amperes, so that the voltage and the current becomes 35 watts, and that 35 watts consumption of electricity will give you that much of bright light energy. So sufficient enough for your scooter or motorcycle. Now you understand what the wattage is going to help you and the bulb or whatever. So on the motor to have that much power, and the bulb to have that much of intensity of light. So for trucks and all, they are going at high speeds, and also they can't stop the vehicle because very load is there. So they need to see the things from very far off places. Yes or no? That's where the truck's lights might be 100 watts. So they might be pulling more amperes from the battery, maybe at 12 volts also, maybe 10 amperes, because 100 watts means 120 watts means, I into V, 12 volts V, current requirement is 10 amperes. So if you multiply 12 into 10, the 120 watts is getting consumed there in the bulb, so that the bright beam comes up very high, so that the 220 watts bulbs will give that much of light, so that they can conveniently go at 100 kilometers of speed also. So that they can see far off places almost for 200 meters also. Then whenever they want to apply the brake, because if anything comes in between, they can control the vehicle because the mass and all. Momentum is high because the velocity is 100 kilometers per hour, and then mass is around 20 tons and all. So they cannot stop it so fast. Okay, understand my dear friends? Similarly, what I mean to say, all about power in DC is nothing but voltage and current. Okay, product of voltage and current is going to be power in DC. But power in AC is going to be somewhat tricky. That is going to be B is equal to V into I into cos pi. Cos pi is nothing but power factor. Okay, I will tell you power factor and all less matter. But however, for this particular class, just think that we are using all the loads are resistive. For resistive loads, the power factor is unity, 1. So V into I into 1 is going to be V into Y. So for our classes, at least for this particular circuit lab 1 base 1, we will assume for AC circuits and DC circuits, P is equal to V into I only, for example, for some time. Okay? When we really work with the great electrical circuits in electrical form, alternating current, at that time we will consider the power factor cos pi thing later in different fashion. But at least for the children circuit lab 1, we will use that P is equal to V into I level. Okay? Are you all comfortable? Shall I remove it off? Anyone has got doubt up to here?